So the next part of this goes into organization, holding, and contingency. And we're going to do a similar thing. I'm going to show you how the models can help support these parts of the plan, what parts of them are really important, and then how to think of them. I want you to think of these things as a package. In the burn plan, they're listed as element 11, element 16, and element 17. The reason I put this arrow and reorganize them is because for me, it helps to think about them in a different order. And the reason that is because if you have to build your org chart and what equipment you need, how do you know? How do you know what you need? You don't really know until you know what your holding and your contingency is going to look like. Then you can decide what kind of organization and equipment you need. So I kind of do it in reverse. So for me, I think about my holding plan. I go in, I look at my fuels and my model, my fire behavior. Then I think about contingency, sort of the what happens if it gets out of my lines. And then I go back and say, okay, now what do I need for holding? What do I need to ensure I've got the burn staying within the boundaries? So that's how I think of it. So equipment and organization, what you're trying to shoot for here is the minimum required organization. This is directly out of the guide, right? It's the minimum required organization, equipment, and supplies needed for each phase of your burn until it is declared out. So into out, not just controlled or contained, but out. So it's what do you need for all those different phases? You could also think about it. We talked about seasonality and different times a year to burn things based on fuel moistures, et cetera, low ends and high ends of your prescription, right? You might need a different organization if you're burning in the spring versus if you're burning in the fall and it's really dry. You definitely need a different organization if you're igniting by hand or if you're using aerial ignition. Those are different org charts. And then for mop up and patrol, as we go through the whole burn, you might have another org chart, or maybe there's a little description of what you need to achieve that part of it. We lose a lot of burns in the mop up part. You know, there's, if you, again, back to those escape prescribed fire reviews, you'll see that mop up and patrol, maybe 2 weeks after the burn kind of is over, you know, there's escapes and stuff. So you need to think about that organization and equipment all the way through. And you can use these tools, this modeling, this fire behavior support to help you figure out what kind of organizations you need. So think about that for a second. And I want to jump here to the next two pieces, which is holding and contingency. So how do you know? So here's an org chart. This came out of the Cyrus burn plan. They have one here for aerial ignition, which is the one on the top. And then they have one here for hand ignition, which is on the bottom. And you can see they're very different organizations. Okay, but how do I know? Like, how many holding forces? What does that mean? How many people is that? Do I need to put an exact number of people in here? Not necessarily, but you should have a general idea of what, is it 3 people or is it 30 people? I mean, those are big differences, right? Is it 3 10-person crews or is it, you know, 2 engine crews? So that should be specified a little bit depending on what the conditions are. So let's go back to our Cyrus unit again, okay? And remember, we also have these interior values that we have to provide some sort of holding, protection, something for. So that should be mentioned in your holding plan too, which is going to go back to your organization and equipment. If I have to protect these plots or this aspen enclosure, what does that look like? Is that people? Is that an engine patrolling? What is it? That should add to your holding plan. So again, organization, equipment, holding, and contingency, you kind of have to think of as a package. So holding plan, this again is right out of the guide. It's the general procedures for maintaining the fire within the project area, right? And to meet our objectives and to protect any of those values. And in the holding plan, you need to point out your critical holding points. If you had to look at that map of fuel models and fire behavior, where would you put your finger to say, this is the, if I'm going to have a problem, this is the spot, or these are the 2 spots where I know I might have issues. So that's a critical holding point. And the other part of it is, what actions are you going to take to deal with that critical holding point? Are you going to staff it up? Are you going to do some mitigation ahead of time? Are you going to burn it first, secure it, and then burn the rest? You know, there's all kinds of things you could do. And what's the organization you're going to need to do that? And then how do you get to the mop up and patrol phase? Contingency plan Okay. And sometimes it's hard to think about these, like now what's the difference, right? Well, the holding plan is when I'm keeping it in the box, right? What am I going to use to just keep it within my boundaries? Contingency is, what extra stuff do I need? Again, this is right from the guide. What additional actions or additional resources, or both, are needed to keep the prescribed fire within the scope of your plan? Okay. So that's not saying we're not going to have spot fires or not going to have slapovers. We probably will. And it might take us a little while to get that stuff under control. We haven't declared it a wildfire, but we might need extra help. So what is that going to look like? Where is it going to come from? A lot of times they use in the guide now the discussion of management action points. And a lot of plans use those. And if you, there's some good examples actually even in this class on using those MAPs. And the idea of an MAP is it's a little table that says, what is the condition? What is it that you're talking about? What's going to happen? What's the condition? What actions are you going to take? And what resources do you need to deal with that situation? So what happens if the fire threatens just the boundary? That could be one scenario. And then you're going to fill out the rest of these. What actions would you take? What resources do you need? What if smoke mitigations are a problem? That's a management action point. Something has to happen because now I'm having issues with smoke. I'm not meeting my smoke objective. It doesn't mean I'm out of prescription or I've declared a wildfire. It just means I need extra stuff to get this handled. Or if you're exceeding your prescription parameters, what are you going to do about that? So that's sort of your contingency plan. So I'm going to just jump to here. This is an example of a table that you might use for a management action point in your contingency plan. So the designator here is that the fire has gotten outside of the regular burn unit boundary. Hasn't escaped yet. You want to be dealing with it. Maybe you don't declare an escape until one operational period or whatever you decide that's going to work for your situation. But so the fact of the matter is the fire is now, it's spotted out, it's slopped over. So the condition is that we've had slopovers. It's more than our resources that are on site can handle. So the intent then is we want to control those spot fires. We want to get our slopovers under control. And we don't want to cause any damage, in this case, the way it's written, to these cultural resources and anything else that's in the area. The actions are that we're going to send resources with water to deal, maybe we have a porta tank set up that was set up just for contingency, and now we're going to use it, okay? Or in this case, it says we can't contain that. So the burn boss is going to request those contingency resources. Still hasn't escaped, but I'm going to get my extra help here so we can keep this thing in a manageable state. And then what are those resources? So, and you're going to spell out what those resources are for your contingency plan. So this is an example of a management action point that you could put into your contingency plan. So basically it goes back to what am I going to do if this thing happens? And you can't cover them all. You have to pick the things that are going to be most important. So here's the differences. Holding is, what do I need for the burn without anything going wrong? Just what do I need to get this done, to implement my burn? Contingency is, what do I need if something goes awry, but I'm still keeping it in my box and I haven't declared a wildfire? And then the wildfire declaration, of course, is when you've hit that threshold where it's not in the box anymore. I can't call this a prescribed fire anymore because it's not within my control. And there's certain parameters. And we'll talk about wildfire declaration later in the week. So we want to focus on holding and contingency. So back to the how do you know? How do you know what you need for your organization? Some of the things you can do, again, this is back to IFTDSS and some of the models and the tools to support these parts of your plan. You could run some scenarios showing a spot fire. What if I get a spot fire here? What's going to happen? How big is that spot fire going to get? How long is it going to take? You can look at those rates of spread. You can look at how far is this to a value. Maybe there's a structure. How far away is that structure? And then, of course, under different scenarios, if I'm burning with a south wind, what might happen? What if I'm burning with a west wind? What if I have high fuel moistures? once you run all those scenarios, you'll have a much better idea of how many resources you might need. A, just to hold it, and then B, what I might want for contingency. So this next part is to walk through the minimum travel time. And this is this is exercise 3. So you might need to finish up exercise 2. And like I said, just run that landscape edit, that step 5 in exercise 2, and that'll get you to what you need for this. This is a pretty quick exercise. And I'm just gonna do a very quick, I've already run everything. I'm just gonna show you the final result because that's where you're headed to with your exercise, okay? So let me stop really quick and I'm gonna switch my screen over. Is there anything that I've covered so far on equipment, holding, contingency that you have questions about as it relates to how to think about those 3 pieces of your plan? Okay, all right, let me go ahead and jump to the other screen here. I'm getting good at this. I say that and then I'm gonna screw it up, so I better not. Okay, here we go. Okay, hopefully you are now seeing, you seeing IFTDSS? Let me get back to my home screen. Yes, yep, shake heads, good, okay. IFTDSS, here we go. All right, so what I'm gonna show you is minimum travel time. And what that means is it's showing fire spread this time. We're not just showing 1 pixel per 30 meter, part of the fuel model map, but we're showing how fire is going to spread from 1 pixel to the next pixel based on fuel model. We know fire spreads faster in grass under the same wind conditions than it does spreading through a shrub or a timber model, right? Things spread very quickly through grass. So the minimum travel time is much shorter in a grass model than it is in a shrub or a forest model, okay? So this is showing fire spread. In this case, you're gonna put a spot fire on the map, you're gonna give it some parameters, and you're gonna say, I want you to run for how, you're gonna give it a set of time, okay? So here we go. So in the workspace, you are gonna go, this is again, I'm just gonna show you the final because I want you to get to it'll walk you step by step through the exercise. So, but that's what the minimum fire spread does, is it shows you fire spread over the fuel models with a given set of time that you told it. In this case, I'm gonna use 3 hours. Okay, so I'm gonna go back to my Cyrus Hill. It's not Cyrus Hill, it's just Cyrus, I think. Anyway, I'm gonna go to my compare weather. So like we did, I showed you the compare where you got to show those things side by side in the prescription, low, moderate, high. I'm gonna show you the final output here with the minimum travel time, but this is gonna be for a spot fire. That's why you need that spot fire shape file to upload to your map, okay? So let me go straight to the map here. And, okay. Oh, that's the wrong one. Stand by, I screwed up. I need to go here. Okay, compare weather. There we go. Okay, now I got it. MTT, this was my output. Okay, so I'm pulling up. So what happened? I ran these 3 MTT runs, which is minimum travel time, fire spread. Okay, and what I ended up with is a low, my low prescription parameter, my desired prescription, and my high end of my prescription. Okay, and in this case, it shows you what the minimum travel time, arrival time is. I really don't like this map. I don't like the way we did these thumbnails. It doesn't really tell me anything because I have no context for it. The best way to view these is on the map. Okay, so once you run each of your low, moderate, high, in this case, you're only going to run 1. You're going to run your desired just so you can get a feel for how this works. So I'm going to scroll down here to view on the map. I just want to look at it on the map. That'll be a much easier way for us to discuss it. Okay, and then someone had asked, how do I switch between flame length and rate of spread? It's the same way in this model. You can use this drop-down box here to switch from arrival time. I'm going to switch to rate of spread because it's a much easier thing to talk about. Arrival time is just how long did it take to get from point A to point B. And zoom out just a little bit. I'm going to change that base layer again on the map. Oh, we're slow again, aren't we? I'm going to add my burn unit boundary. See if I can really confuse it. Okay, hang in there with me. It's going to work. There we go. See, slowly but surely. Okay, so here's, while this is drawing. So what I did is, let me zoom in just one more click here. You can see that shapefile I gave you, the spotfire.zip, is going to be a little teeny tiny polygon right there, that orange square that just popped up. That's our spot fire. Okay, that's that area of the burn unit where it has that continuous set of shrub. Okay, and the thing that really is the kicker is that there's a house right up here in the corner. We have a value. Okay, it's going to show up once this imagery turns on. There it is. Okay, there's our house right there on the map. So here's our orange square. So I told it there's a spot fire right here. I gave it the parameters of the desired prescription, which was our fuel moistures. And I also gave it a wind direction. In this case, I changed the wind direction. I gave it a southeast wind, 160 degrees. So I want the wind coming up out of the southeast, okay? I want to see how long it's going to take that spot fire to grow from the edge of my burn unit towards this structure. How long do I have in order to deal with this? Remember, I'm trying to decide what my organization should be and how I should inform my holding plan and my contingency plan. So IFTDSS does a really great job of giving us these outputs so I can see the distance, all right? So part of your exercise is going to figure out the distance. We have a distance tool here called measurement. Just pull that guy up when you get to that part of the exercise, and you can measure. No, it's not letting me right now because it's being really stubborn. And you can use the measure tool to say, well, how far is it from the edge of this to that house? How far did it grow from outside of the burn unit to where it is in 3 hours? Remember, I set the time at 3 hours. The simulation time is 3 hours. So this can, as you can tell, this can be a really useful tool in developing those holding parameters and equipment and resources that are needed for your organization. Sorry, this thing totally got stuck. So the toggles up here, we can go from our low, which this is in the way, we can't see it. We can go to our desired, which is what I just showed you, and this is the one you guys are going to run. And then we can go to the high end, which sort of blows the thing out of the water. Remember, we're dealing with a shrub model, and you can see the spread in 3 hours is quite significant. We've got grass and shrub mixed, so it's a very fast moving fuel model. Okay, so that's what MTT does, minimum travel time. The red lines on here are the flow paths. It's the, you can see it ran through the orange. We could turn on those fuel models, and I bet you anything, those orange, I know it, those orange pixels are our flame length, or sorry, they're our rate of spread here. And if we turned on the fuel models underneath, that's going to match up with that shrub model because it's moving really fast through those overstory of shrubs. Okay, so that's kind of how MTT works. So let me go ahead and I'm debating if I want to. Let me flip back. You're going to start your next exercise, exercise 3. But before we do that, I want to show you one more slide. I think that will bring this together since I cut this short just a little bit. So let me switch back to my slideshow here, and then I'll turn you loose on your next exercise. Okay, let me go back over here. Oh, I'm getting so good at this. It's a miracle. All right. Any questions while I'm setting this up? Okay. So in your holding plan, what I wanted to show you, this is the holding plan from the Cyrus burn plan. And this is just if I had, that's all that's in the plan right now. Wouldn't it be cool if in your plan, you had this map as well? this is all those values that are you care about inside that. So you point those out, you can see the flame lengths that match up with those values. That would be really informative for me in my critical holding points and actions. Another one is what we just talked about with this minimum travel time. Again, here's the page that's in the burn plan now. And if you add that, this is the critical area of concern here, right? This north line, because we have that house up here. And then this is the spot fire outputs from that MTT run that I just did that shows you under desired conditions, maybe we can handle this. We'll have to decide what resources we need. This is 3 hours. So if I want to catch it in an hour, of course, it's going to be quite a bit smaller. Maybe that's totally doable and that's good. But 3 hours on a high end of our prescription, I don't know, we might want to rethink that a little bit, or maybe we beef up our holding resources and we do it anyway, because that's what the fire behavior we need to achieve our burn. But wouldn't this be a much better holding plan by using these images? And that tells the story to me pretty quickly without having to read through all of this text. I can immediately look at this, look at some captions, and get what I need to, and tell my story. This is another one with contingency. So here's that management action point idea that I talked about. And then here's showing my greatest areas of concern. This part is a concern. And if I have a south wind, that's what the blue arrows are indicating, the wind that might cause my problems. If I have a south wind, this is the area I'm going to need to pay attention to. What kind of contingency am I going to need for that? What if I have a northeast wind? I've got this continuous fuel model that's causing these high flame lengths. Same thing over here. So these are the types of outputs that you can take from these model runs and really help beef up these plans and inform the resources you need. Okay, so I'm going to go ahead and stop there. And I want you guys to get back to your exercise 3, maybe finishing up exercise 2 if you need to. And then we'll reconvene. Yeah.
I've got a quick question for you.
Yeah, go ahead.
So at that point now, you know how big the fire has the potential of getting under certain environmental conditions. What are some tips that you have for then what to do with that information on how to select the number and type of resources that you need?
Yeah, good idea. Okay, so let me go back here just real quick. That's a great question. So how do you know, right? Back to this, how do I know? So if I have a model run here that shows that in 3 hours, now I could figure out, remember we could use line construction rates for different resources. Behave has a contain module in it as well that can give you some of that information. So, you got to think what's reasonable. So for a holding plan, your on-site resources, if you have a spot fire and it grows, maybe it's 25 acres, that might be a little bit out of the realm of something, a holding resources on site for a regular old burn. 25 acres is a lot, right? So could they really get around that? No, you're probably going to need contingency resources. So you're going to have to start thinking of area, and you can get the area, you can map the area of this spot fire under different time frames in an hour, in 2 hours, in 20 minutes. What is it? And then knowing line construction rates and what resources you have both on site and that you can call maybe from your neighbors, that could help you calculate, I need 3 engines. I need to call my neighbors. My contingency plan is going to I need 3 engines available to me to call from the neighboring forest to be able to come over if I have this issue. Or on site, maybe I'm going to divide this burn unit into 2 pieces, and I'm going to beef up my holding resources when we burn this north line. I'm going to want an extra engine. I'm going to want a dozer or 2 dozers, whatever. So look at those line construction rates. Look at the size and area of your spot fire potential, and that should help you calculate what kind of resources you need. Is that kind of what you're getting at, Heather?
Yeah, it was. Yep. I was curious if any other cadre had any other tips on how to go about calculating the number of resources that they need when they are planning or replanning a burn unit.
And we can talk some more about this in our little breakout groups too, because there's a lot more to contingency and holding and organization here. So, and everybody has a little different way of doing it and has some great ideas that, we learn from our peers and stuff when we do some of these things. So
Yeah, that sounds good. We can cover it a little bit tomorrow in our next breakout.
Yeah, that'd be great.
Well, hold on, I gotta turn off my speaker. Disregard.
Oh, okay. Hold your thought. We might be able to pick it up at the end too. So why don't you guys go ahead and we'll do the part 3 of your exercise, okay? And then we probably have a few minutes at the end to.
Here I am.
Oh, go ahead. Yeah.
No, I kind of going back to Heather and modeling and everything and utilizing like the IFTDSS toolbox has multiple tools in it. IFTDSS is a tool, but it's also a toolbox with several tools. This is one of them. But I would also state that, this is great for, your empirical evidence of your professional judgment as well, based on, what you know about your home unit and whether or not, ground resources can even manage anything like this. And you have air resources available, and this is their rate or whatever it is for production on the ground. And those are things to consider too. So it's, again, it's not just looking at the numbers that it's spitting out or what we're calculating out for line production rate. It's just simply that is more of the analytical part of this process that we can utilize and really inform ourselves and show that we have gone through this process and this is what we need. And this escape, if you will, or this slop over, I shouldn't say escape, but this slop over and with our contingency resources based on our professional judgment and what we're seeing from the model together, build what we need for containment from our contingency resources in X amount of time or whatever it is. And that's all written up as well. So it's not just like this picture and these resources, but you're also writing this as well as you work through the burn plan and your contingency resource needs and things of that nature.
Yeah, you can't just slap a picture in there and walk away. You have to have some some justification and some explanation about all the things that Paul just mentioned. So, and you might not even this might be something that you do on the side and you say, okay, now I have an idea. You might not need to put this in your plan. If it helps inform your plan, great, you should use it. But in some cases this is just something that's backing up kind of what you thought and you can write it up quickly. That's fine too. Remember, these are just tools to use as appropriate and relevant. And they're not, as Lowen said, this isn't gospel. This isn't perfect. This isn't exact. But it does show that you use some of these supporting pieces of evidence to help justify why you're doing what you're doing in your plan. So,
Kim, one thing that you may find that folks may find as they do this is under that high end condition, you might say, we don't have the contingency resources available to handle that. And therefore, we will not burn under that set of conditions if the winds are coming from that direction.
Right.
And so this is a really wonderful tool to be able to help you establish what your prescription is. And in your final project, we asked you to develop a landscape description, but you may use the outputs from IFTDSS to describe some of those areas around your burn unit that are particularly problematic, either doing a general fire behavior run for your area to show, like Kim showed, those highlights of areas where the contingency or your areas of highest threat, or being able to do an MTT run like this to show how it could spread. And you do a run like that, and you wouldn't say to your agency administrator, let's say, well, this is what it could look like. We might just burn this house up if we got a spot fire. What you might say instead is, this is why we're not burning under these conditions, and we don't want to burn this house up. So therefore, we're going to do this risk management strategy of burning when winds are only coming from the other direction. And that gets ahead of a lot of these problems that you mentioned prior to what these reviews reveal, which is that if people had done that modeling like you've done here, they would know these problems, or at least be aware of them prior to, instead of implementing on days when you end up with a spread like you got there.
Yeah, I think that's good. And Phil just pointed out too in the chat, remember, these are the burn plan calls for the minimum number of resources that you would need to execute this burn, right? And you can certainly have a range, but you have to say, I can't do this burn with any less than this. You have to have that part. And then you can augment it with other things, And again, it might be wind direction. It might be, having that, you might need that kind of fire behavior to meet your objectives, right? Especially with this particular burn. You might need to do some mechanical treatment along that north line to reduce your flame lines. And then you could show that, we're gonna roller chop that, that juniper, get it on the ground, at least immediately adjacent, so we can catch a spot in that. So that might be something that reveals from doing this exercise that you change sort of your pathway to implementation. You're actually going to do some mitigations that you might not have done because you didn't realize, I didn't realize how fast that could get that big. So like I said, this doesn't necessarily just apply to sticking it in your burn plan in the text, but it's a preparation thing that you should be thinking about and using as you're considering how to implement some of these projects. Again, when I said the very beginning of all this, how this spatial modeling applies to fuels planning in general, and prescribed burn planning specifically. So this is a tool for your job, basically, not just for burn plans.